With that said, I'll hand it over to Victor.
Thank you. Yes, session will be recorded and slides are already there. So just like scan this, the barcode, and you will get the to my website where all the resources are there. Rumor has it that there is 8-hour version of this talk existed somewhere on the internet. I cannot confirm nor deny, but it's a lot of things that is going to happen in this particular presentation. So everything. Most of the thing in the last couple of years happening somewhere in internet, specifically on X or Twitter or whatever, and the essence of this talk, or like a beginning of this talk, has also started in the Twitter. So there was a conversation with some folks from the community. I used to work at the Apache Trino and the Star Tree at that time, and the people were asking like, what's the ultimate way to query the stream? And my boss, he's also in the room, so yes. So and he was like, yeah, it's probably going to be a good talk. So here's this talk, like how to query stream. Very simple question, very complex answer, and also to be on kind of like on trend of these like existing events, I decided to make every slide in the Studio Ghibli style. So you will get a little bit more entertainment with this presentation. So now it would be much better. We're going to be exploring the world of streams. I came from a company called Confluent, and I came from the world of Kafka to bring you some of the interesting stories. Essentially, that's what we're going to be doing. That's why I'm saying it's kind of a simple thing to talk about, but not very simple answer, because there would be multiple it depends type of thing happening in this presentation. My name is Victor Gamov. I work as a principal developer advocate at Confluent, and I speak to developers. I'm building demos, talking about technology. So you can talk to me about all things stream processing, streaming, real-time analytics. I do have some of the experience in these new things or two. Wrote the book about Kafka, but I'm here not to brag about myself. We're going to jump in. Everything starts simple. Back in the day, everything in one place, one database, one application server. Monoliths are easy to maintain. We thought that would be the case. But over the time, this grew bigger and bigger. Maintenance would be difficult. Some other interested parties would be interested to getting data out of this monolith. So that's why we come up with interesting solutions like ETL and change data capture technologies, where we're taking some of the things from one system and moving this to another system. So that's why change data capture allows to change the things that happen on database level and push it into the to the places where the changes are needed. And historically, it becomes a revolution of the data pipelines. Different pipelines or event-driven microservices that were powered by this data that moved from one place to another. And historically, we use one pretty cool piece of technology for this. It's called Kafka. And Apache Kafka is a fundamentally distributed transaction log, and that's why we have a lot of logs here. That will represent a partitions that happens in Kafka. Your data would be moved through Kafka. And this is not, it's not controversial. I stopped doing this like a show raise of hands who knows what Kafka is, because everyone knows what Kafka is. Hopefully, show of hands who knows what the Kafka is. All right, good stuff. And Kafka, essentially, that's the place where data will end up one way or another. Change data capture, ETL, any events that will be generated by microservices, and so far and so on. Now, two types of stories or two types of data that we want to explore in this particular presentation, and they would have kind of like a distinct accent to those things, is real-time streams or online transaction processing streams versus OLAP streams, kind of like analytical streams. And when we're talking about the OLTP type of streams, we care about each individual message. We care about each individual transaction. When we're passing this through the Kafka event, we care about this. So we want to see either what were the latest transactions for the last 5 minutes for that particular credit card number, versus OLAP streams, where we more care about whole story. What is going on with the consumer power of buying stuff, so we can analyze based on some of the data how much people spending on their groceries based on the data that we have from their transactions. That's how I would distinct the OLAP streams versus OLTP streams. Now, I'm gonna quickly draw a set of tools that we're gonna be covering today. We're going to start with the ecosystem tools. Specifically, Kafka Connect is the Kafka framework that comes with Kafka. Kafka Streams also framework comes with Kafka. We talk about this emerging new type of database, streaming databases or streaming SQL. We're going to talk about one of the interesting subject that also kind of like stands in between of the things, real-time OLAP. Obviously, data warehouses and data lakes. And at the end, I think, I don't want to create any spoilers, but I think that it's kind of like would be perfect-ish solution for this particular case for solving this type of thing. So we will see. It's not I will propose this to you, and you will be the one who will decide. Now, Kafka Connect. So Kafka Connect, it is a framework that comes with Apache Kafka, allows to integrate with external systems. Usually, general knowledge or general community agreement is that suitable for stuff that you can manage because it's an additional part of infrastructure. Usually, if you want to use Kafka Connect to listen to changes from your Kafka topic and push it to some operational database or transactional database, you will be relying on those capabilities. But it's not always true because you can use connectors that will be offloading the data to not transactional states, but transactions are supported. And if we're talking about just a general OLTP databases, people know how to query their Postgres or MySQL or whatever they have. And conceptually, there's a separate infrastructure from your Kafka that will be running this connector, and data will be landed into this transactional operational store. Usually, the way how I envision this, we will just take in this every 10 minutes and update this table. It's not going to be real time. Latency would be low. Data size needs to be managed because these operational databases are usually not suitable for doing analytical queries. That's why we have data warehouses and all this kind of stuff. So, but it's the case. It's the real opportunity. So you can create a connector, put this in your MySQL, boom, you're querying the stream. Now, this contraption is called Kafka Streams. Another thing that allows you to do kind of sort of querying the stream. And the cool thing about the Kafka Streams, it supports both use cases where you need to care about individual record, like your transactional record, and if you're interested in the story, like running some sort of aggregations. So in transactional sense, Kafka Streams has a very intimate connection to Apache Kafka. A lot of technical decisions that were implemented in the Kafka Streams, they were inherited from Kafka architecture itself. So data ingested from the topic, it gives you nice API to read this. You don't need to, you feel like if you're Java developers, you feel like home because it's implemented the Java util streams standard library. Key table is the abstraction that allows you to extract based on the key if you're interested in particular transaction, and everything is in memory, highly scalable and relies on the Kafka, but also the scalability would be limited by Kafka number of Kafka partitions. With these capabilities, there's no way how you can easily query per se if you're not doing anything Java. So you need to rely on a thing called interactive queries, which is essentially also a framework that allows you to expose any type of, it can be REST, it can be gRPC, whatever RPC you want like to expose. With analytical sense, you have full-blown Java API, you can write your aggregations, write the processing functions, it's cool. Yeah, if you like to write Java and compile code and deploy code and support this code and after that scale this code and stuff like that. It's pretty cool. It's there, you can write analytical stuff with Kafka Streams, but unfortunately for every use case, you will have to implement kind of like a piece of topology, either extend on one new piece of topology or adding more and more. Spoilers, in a few minutes, I'll show you that this same idea can be taken into a very extreme point that same architecture will be used, but only through SQL. Because people also didn't like to use Java stuff there. So, Kafka Streams also very popular tool for doing the querying streaming information. Again, interactive queries, if you need to expose this to outside world, you need to figure out these protocols that you will be using to expose the data. Now, this is how I envision this, and this is how I communicated my ideas, that you kind of like look into the stream, and based on the key, you can do lookups, like you do like filtering, and you, this is something like you do filtering, and this is maybe you aggregating data somewhere in some sort of like a key table. So that's how you would, you know, envision this or visualize this approach with the Kafka streams. Now, very interesting trend that happened with the last couple years is emergence of the streaming databases. Streaming SQL, and without going into much of the details, I would like to propose, based on some of the, again, general knowledge and the books written by esteemed authors, three main components that will distinguish these streaming databases from other type of software. So first of all, we're using SQL for queries, one way or another. Like you or not, SQL is the thing that we have, the best thing that we have. Now, second thing is that the streaming sources are first-class citizens in this world. So either would be native integration with Kafka, Pulsar, Kinesis, or something, or there would be some high-performance connector, so the people who writing these SQL queries, they don't need to worry about how to ingest this data. And the third one, and this is an important one, that there should be some sort of way to have a persistence. So some of the results that you do on this like streaming queries need to create materialized views or some sort of the ways how the data is persisted. KSQL DB, materialize, rising wave, time plus. Does anything of this ring the bell for anyone? Okay, few people heard about something. We'll go very quickly here. I think the KSQL, that was the great idea to, oh, wait a second. But there's an elephant, or I would say squirrel in the room, right? So, like, Victor, you mentioned SQL, and you have a native integration with Kafka. What about Flink, right? So, is Flink a database? I don't have an answer for you today, but I know who has it. David Anderson, a very important and very well-known person in the community, recorded a very good video, which I have a code for you. Go watch this, and this is how you would learn that Apache Flink is not streaming database, but you can use Apache Flink to build something like streaming database or whatnot. Also, you will get, while you will be there, click subscribe button. It's a YouTube channel called Confluent Developer. We're creating content, new videos every week. Please subscribe, enable notification. Thanks so much for coming for my TED Talk. Now, KSQL DB. So there was a cool idea with Kafka streams. It was light, it was performant, worked great with Kafka. What if we'll take this framework and build something that will be talking SQL, integrates with Kafka nicely, and provides this some sort of like abstraction that can be also persisted. So it uses this stable abstraction, but the persistence was going to happen on the Kafka side of things. So that's why I'm putting this kind of like a streaming database, because it's not separated from the Kafka. It uses Kafka as a source, but also it's uses Kafka as a storage for some persistent queries. Yeah, basically Kafka streams, but with SQL. You don't need to write your Java. You don't need to write your compile this. Just submit the query, and everything was going to work. Materialize. Anyone heard about Materialize? It's kind of cool one because it has some cool ideas. Specifically, we talk about this integration with the streaming sources. There's a materialized view that you can create and you can query after. And a very cool feature that I also see in many of these streaming databases is that a wire-compatible protocol with Postgres or whatever database is popular. But most of them, they support Postgres, meaning that you can connect your tools to this database. It doesn't mean you can use your Postgres queries against this system. Sometimes you can, sometimes you cannot. But you can connect the tools, drivers, and emit queries against this materialized with your existing application, which is neat. I think this is a very neat feature. Rising Wave, if you heard about Rising Wave before, if I would say that it's kind of like a Flink implementation in Rust. Some people, for some reason, becomes like very sensitive about this, but hey, fight me. Flink implementation in Rust, plus it actually has a persistence. So Rising Wave, it's the non-JVM system, allows you to write your materialized view using SQL, and also you will be able to query, say, like you can also expose this PostgreSQL compatible protocol, and that's actually pretty cool. And it has like a native integration with Kafka and Pulsar and Kinesis. Now, this is how I envision materialized view on top, or like how I visualize or how I communicated to ChatGPT, how I would like to see my materialized view on top of Stream. This is one particular interesting. I spent a little bit of time working in this new type of databases. Anyone using like Apache Pinot, ClickHouse, Druid, something like that? All right, few people. So that's why the gentleman is not entirely drinking Pinot. I guess it's probably something else. Maybe Pinot Grigio, no? No? Or maybe just the juice with electrolytes. The system is designed for high concurrency, low latency, but still support analytical queries. Native integration with the streaming and batch sources, say the ClickHouse and the Pinot, they have a very high performant integration with Kafka, so latency between how this ingestion gonna happen into database like a Pinot or ClickHouse and the time when you execute the queries, also very minimum. Plus, you're using this for query with traditional SQL, of course, and also kind of like analytical queries on top of the real-time data. Think about you go into LinkedIn and seeing who watched your profile. I'm going to be doing this today because hopefully some of you will check my profile. And more importantly, I can do this like minutes after my talk if people are going to go and Google me and watch me. And this was achieved by using these analytical queries on top of the streaming data that LinkedIn has. Now, data warehouses. I don't know much about data warehouses except that logos are blue. I don't know, like this probably some committee sitting there and they deciding like which the accent of blue we're gonna use for a logo. So essentially that's the idea of your typical data warehouse, but taken into the cloud. Traditionally, ingestion happens on the batch size, but some of them support in streaming sizes. And usually, they inclined more on the batch processing, and performance can be even worse when you need to deal with larger data sets and stuff like that. Data lakes. We have our data, we put it there, we will figure out later how we're gonna read this. That's how I understand data lakes. As you can see, I'm not very bright, but hey, like this explanation works for my grandmother, so like we can talk about data and stuff. So storage and compute are radically separated, and this is important because we're on this like Iceberg summit, and this is where multiple compute providers providing their services on top of this storage that is Iceberg. Reads are slow, streaming is historically difficult. Started as GFS, now it is everything is in S3. Didn't help. We changed ETL to ALT, so instead of like we loading, transforming, and uploading, we're now doing extract it, load, and we'll figure out when we will be reading this. Schema on read. And the Apache Iceberg is here helping with shaping the storage. And this is good because there's lots of cool features available in Iceberg that makes it a great choice for storing some data. Time travel queries, schema support, usually that's something that people complain when we're talking about the data lakes and how data will be structured and how we're going to be reading data when we're reading this data. But somewhere in between, there's missing link between our operational state and our analytical state. And I hope, again, that solution that I would propose is actually missing link here, because the solution that I'm going to talk just for the last 5 minutes called TableFlow. So TableFlow is essentially a engine that takes Kafka topics and present them into Iceberg tables. So that's how I would like to communicate this idea to ChatGPT, and this is what we have. So we have a stream of data that goes this, and after that we take this chunk of the data from the stream and present this as a Iceberg table. And existing tools are working. Still SQL, you can use tools to query these tables using, I don't know, Trino. That I use the Trino because it's here in my example. And so the way how it looked like in my Confluent Cloud, I do have my Kafka topics. There's some flight data that constantly pumping. I hope it's constantly pumping. If it's not, we will fix that in a second. So we have some data about flights. Now, it would be cool if I will be able to just like flip the switch, and after that I start querying this data with my SQL tools. Oh wait, I can do exactly that. So inside here I can always select the table flow. So this particular table already enabled with table flow because it says table flow syncing, meaning that there's an engine that will be constantly updating this, and on the other side, have you ever tried this popsicle thingy? It's pretty cool, kind of like a SQL client. It has support for Trino as well. Shout out to my friend Robin, he showed me this, and it's actually a pretty cool one. So I do have a connection to my local host. On the local host, I'm running my Trino, and Trino has connection to my table flow. Inside the Trino, we're defining this catalog. Ooh, you're not supposed to see this. Iceberg catalog or resting point, but instead of URL, we're using table flow URL. I'm using key and secret, and now my my Trino can do stuff like this. If I will go, where's my table flow? Yeah, that's my flight information. Now, and I can run different select queries. It will call Trino. Trino will call table flow, and you know, when I will call it the next time, data will be different. Say this is the query that shows like a total number of canceled flight for the last hour. Very analytical query, was able to run it here on top of the data that is already in Confluent Cloud. Now, some people might ask, okay, so like it's a raw data. Can I use the same approach for, say, bronze architecture? Yes, you can even do a little bit shaping of your data before it land into would land into my data flow, table flow. So through some streaming SQL. So for example, I do have this table that I derived called like enriched flights, and my enriched flights would look something like this. Some additional information that I'm getting from here. I derive this information from my flights table, but I do a little bit kind of massaging of the data, while providing like a nice way where the delays happened on the morning or night and all these kind of things. And result of this would be materialized inside Kafka topic. So the Flink will be doing Flink thing, send the data into my Kafka topic. And the result would be also available in my, if I go to my tables, my topic, and another one, enriched flights, also available through table flow. Let me show you quickly. There's another tool, Superset, that uses Trino connection, and if I go to refresh, I can see here, I can have enriched flights and just the regular flights. Just works out of the box because Trino and works with table flow. It's Iceberg, and everything is exciting. Now, one moment of your time, and I will let you go, and also I will be available for enhanced interrogation. Like I said, there will be no answers here. It's a lot of information for you to take in, because we are adults, and this is the thing that I learned being adult. I hate this, it sucks, I pay the taxes, but there's no right solutions. There's not right or wrong. There's the things that work for you or don't work for you. For example, there's some things that you already know. you know your Postgres database, you know your Kafka Connect, and it's fine. You can write your queries, and it's not so bad. You can use it, it works for you. Some people like performance. We're not going to talk about this, but performance would be our choice of the solution. And most importantly, in my opinion, because I work with community, and I cannot stress this enough, community, brightness of the community, openness and conversations, it's very important for choosing the tool. You don't want to pick up the tool where the community is super toxic and everyone is screaming at each other. I'm looking at the Scala. Yes, in Scala, you need to have a PhD in order to ask the questions. In Iceberg community, you don't. You're asking questions, and there are very smart people helping you to understand. Community is important. Like I said, you go into the very interesting journey because there will be multiple tools. There will be multiple different dragons, like area of exploration. Let's put it this way. But there will be some monsters. And with this, my name is Viktor Gamov, and as always, have a nice day.